In this video, I'd like to talk about the math question of the day for Wednesday, August 9th, 2023. And with this problem, we need to find the perimeter of this triangle ABC, this larger triangle here. And questions like these are typically seen in geometry classes. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And we can start by using some of the information that we were given. Notice that the line AC and RP, these are parallel lines, which can be denoted with these arrows here. And with parallel lines, we can know properties about the angles when we split these lines with what's known as a transversal, or in other words, just some line, this line AR, that cuts between the two parallel lines. And with parallel lines, we know corresponding angles are equal. This angle A will be equal to the angle PRB right here, since these are corresponding. Now, likewise, this angle C will be equal to this angle RPB, since these are corresponding angles, where our parallel lines were again cut by a transversal, though this time it's a different transversal, this line CP or CB. And what we can also see is that when we compare the big triangle ABC to the triangle RBP, that they share this angle right here, B. This is the same angle in both of those triangles. And we can notice that the two triangles are similar. They have the exact same set of three equal angles. So let's write that. We can say that triangle ABC is similar to triangle RBP. And we do need to be careful here with the order we write these letters. Essentially, the angles have to match up. Angle A has to match up with this angle R here, this vertex here. Angle B, of course, matches up with B, and C matches up with P. So be careful which order you write that the two triangles are similar. But once we recognize that the triangles are similar, we can notice that their side lengths are then proportional. In other words, this smaller triangle, every side of the triangle is multiplied by the same number to get this bigger triangle. So we need to figure out that proportionality constant. What do we multiply the smaller triangle by to scale it to be the bigger triangle? Or we can write it out as proportions. We can say that this side length RB right here is proportional to the side length AB. Again, the order matters here. RB divided by AB, this would be equal to our proportionality constant. We can figure out what we multiplied by to go from the small one to the bigger one, or vice versa. And that proportionality constant will be the same when we compare any of the corresponding sides. Meaning that if we look at BP, we can then divide that by BC. We can write BP, the ratio of BP to BC. This is also equal to that same proportionality constant. And if we want, we can also say that this third side, RP, when divided by this long side, AC, this would also be equal to that proportionality constant. So let's figure out what we need to know here. We need to find this missing side length PB, since ultimately we want to find the perimeter of this big triangle, and we have all the information we need except for this side length here. And let's give this a letter. We can call this x and then try to solve for that. And we can use any of these ratios to help solve for x, though we do need the ratio between BP and BC. So let's start by writing that out. We have x, that's our BP or PB, and we'll divide that by BC. And it gets a little bit tricky here, but BC is this length C to P plus this length P to B. It's 10 plus x. And then this will be equal to this RB divided by AB. We could try to use RP over AC, but we don't know what RP is. So this ratio won't be too helpful for us. We can come back later and figure out what RP is, but at that point we will already have the information we need to figure out the perimeter. So we'll need to use this ratio here, and we can say that RB, that is 7, and we'll divide that by AB, but AB, notice, is the sum of A to R and R to B. We can add those together to get this total length, and we have 14 plus 7, which is 21. So at this point, we can actually solve the equation. We need to solve for x, so we need to get it out of the denominator. And to solve a rational equation like this, we can multiply both sides of this equation by this denominator here, this 10 plus x. So let's do that. We will multiply each side of this equation by the expression 10 plus x so that we cancel out this denominator. And we do that on both sides, 10 plus x. So on the left, they cancel. We just get x on the left. And on the right, this simplifies to 1/3. And we have 10 plus x. Now, let's also cancel out this fraction. We can just multiply everything by 3, so that 3 times by 1/3, that's just 1. We have 3x. The 1/3 and the 3 cancel, and we just get 10 plus x, which is now a one-variable linear equation, which we can solve by putting all the variables on one side. Let's subtract x on each side. So we get 2x is 10, and dividing everything by 2, we get that x is 5. So our missing side length is 5. Right here, we can plug that in. And this should make sense, because notice that the small triangle compared to the big triangle is 1/3 of the size of the big one. Or in other words, we take the small side and multiply it by 3 to get the big side. Since remember, this length here, AB, is 21, and this length here, RB, is 7. Whereas this length here, CB, that is 15, and this length here is 5. So from each of these smaller sides, we multiply it by 3 to get the bigger triangle. And we can go in reverse if we want. If we wanted to find RP, we just divide by 3, going from the big triangle to the small one, meaning that this is 6. So we now have the information we need, and we can now find the perimeter. And the perimeter, remember, we just add up the lengths of the outside. We have 18 for AC, then we add 15 for BC, and then we add 21 for AB. And that gives us the perimeter of the triangle. And after adding all these together, we will get 54. So the length around the outside of this triangle, ABC, is 54 units. And what you can notice is that if you find the perimeter of the smaller triangle, if we add these together, we get 11 here plus 7, which is 18. Notice that this perimeter is exactly 1/3 the perimeter of the bigger triangle. And that's not a coincidence, because these are similar triangles, and that will always happen. So if you needed to, you could find the perimeter of the small one, figure out that proportionality constant, which we know is 3, and then just multiply by 3 to get the perimeter of the big one.